So EOT question number 1. So in this we need to discuss question number 1 and 2 from page number 8. Okay, page number 8. Actually question number 1, 2 and 3, but 3 we will discuss with the next objective, next EOT question. So first question number 1. Summarize the steps you might use to carry out an investigation using scientific method. So question number 1. What is scientific method? Scientific method is a series of steps that the scientists follow while conducting scientific investigation. So what is scientific method? Scientific method is a series of steps, means a pattern, okay, a pattern that the scientists follow while they conduct a scientific investigation. A series of steps scientists follow while conducting scientific investigation. Then what are the 6 steps? Okay, steps of scientific method. Steps. Number 1, state the problem. Number 1 is, what is the first step? State the problem. And what is the step 2?
Gather information.
Gather information. And step 3?
Form a hypothesis.
Form a hypothesis. Step 4?
Test the hypothesis.
Test the hypothesis. Step 5?
Analyze data.
Analyze data. And what is step 6?
Draw conclusions.
Draw conclusion. Okay, so these are the 6 steps in scientific method. State the problem in the first step. What do we do in this step? In this step, if we observe something, we ask a question. For example, you see there is rain. So you ask a question, means you are very small, you are curious about the rain, you see the rain and you ask why the water, means why there is rain, why the water is falling from the sky. So that is the first step, asking question. So when you observe something, you ask question, right? So during the first step, we ask the question about our observation. Why the sunset in the east? During the time of sunset, why its color is red color? And means at noon time, its color is white. During the sunrise and sunset, why the color of the sun is red? So we observe that, then ask the question. So that is the first step. Or we can say, in the first step, the scientists decide what needs to be investigated. Okay, so that is the state the problem. Second step, gather information. What scientists do during this step? Scientists collect information from authentic sources. What are the authentic sources? Books published by great universities, authentic websites, scientific journal, etc. Then step 3, form a hypothesis. So what is a hypothesis? A hypothesis is a possible explanation for the problem, means possible explanation for this question based on the information that we have collected in the step 2. Based on our observations and information, we will make a possible explanation, a possible solution for the problem. That is called a hypothesis. So a hypothesis is a possible explanation for the problem. What is the problem? The problem is this one, right? The question we asked. So a possible explanation for the problem based on the information that we have collected and the observation we made. Or we can say a hypothesis is a prediction. We are predicting the solution for this problem, okay, based on the information that we got. So what is a hypothesis? We can say a hypothesis is a prediction. A prediction based on the information that we have collected. Then fourth step, test the hypothesis. What are the different methods to test the hypothesis? We have three methods to test the hypothesis. What are the three methods? Number 1, by conducting experiment. By conducting experiment. Can you say the next one? What is the next one? By making model, and means making observation. We will write the next one, okay? And number 3 is model, right?
Yes.
Number 3, building model. For example, we cannot test everything in the laboratory. Means if we are studying about the space, we cannot create that in the laboratory. Means we cannot do that experiment in the laboratory. So we make observation in the space. We use the telescope to make the observation. Or if you are studying about a solar system, so we create a model of the solar system. If you are studying about the atom also we cannot see the atom, right? Yes. So what do? We create a model of the atom to study about it. So if the object under study is very big, if the object under study is very small, or if the object under study is hazardous, dangerous, like volcano, nuclear radiation, we use model. We build a model, a simulation. Simulation is example for computer model. Okay. Then next, analyze data. How do we analyze the data? By, we can make a graph, right? We can plot a graph and we can make the data into easy to read table, okay, to analyze the data. And based on our analysis of the data, we will make a conclusion whether our experiment, whether our data support the hypothesis. If the answer is yes, okay, if it is support the hypothesis, we will go back to step number 4 and we will test the hypothesis again and again, okay. We will continue the experiment again and again. We will repeat the experiment. If our answer is no, if our conclusion is not supporting the hypothesis, then we will go back to step number 3 and we will modify the hypothesis, okay. If the answer is no, if our data is not supporting the hypothesis, we will go back and we will modify the hypothesis, or we will change the hypothesis completely. Okay, so this is the scientific method. And our second question is here, this question number 2 from page number 8. Define the term hypothesis. How will you define the term hypothesis? How to define the term hypothesis? Can you say?
Possible explanation for the problem.
Or a prediction, right?
Yes.
Or it is a prediction. That prediction and possible explanation are based on what? Based on the information and our observation, okay, that we are doing here in the step number 2. Then what are different methods to test the hypothesis?
Experiments, making observation, and building a model.
Very good. Okay, the next two we will discuss EOT question number 2. EOT question number 2 is, explain why it is important for scientists to avoid bias. In that we will be explaining questions 3, 5 and 6 from page number 8. So page number 8, question number 3, 5 and 6. So what is question number 3 in page number 8 of the book? Question number 3 is, why is it important for scientists to avoid bias? So what happens? If there is bias while conducting the investigation, the scientist will prefer one reading over another, one observation over another. Means the scientist expectations can influence the result, can influence the recording and the result of the experiment. So scientists expectation can affect the recording data and conclusion of the experiment. Okay, like for example, I will means if we are conducting the experiment, I may prefer the positive reading, means positive observations, and we may ignore the negatives, means drawbacks. For example, we are making a medicine, okay, we are making a medicine in our company, and we are testing the drawbacks and the benefits of the medicine. Is there any drawback? So while conducting that experiment, so my expectation, that is, I think, yes, the medicine will not have any drawback, it will be perfect. That's my expectation. That expectation can influence the observation, recording the data and the conclusion of the experiment, because I may take the positive reading seriously, or I may prefer the positive readings, means the benefits of the medicine, the advantages of the medicine, than its drawbacks. Okay, so if you are a scientist, means we have to avoid bias while conducting the investigation. So how to avoid bias? We can avoid bias by recording all the observation, by recording all observations accurately. Okay, so by being objective while conducting the experiment, we can avoid bias by being objective while conducting and recording the experiment, means recording the data. Being objective means recording everything accurately, the positive reading, negative reading, expected reading, unexpected reading, everything. Record it accurately. Record everything while conducting the experiment. So that is called being objective. Okay, recording everything, the expected reading, unexpected reading, negative reading, positive reading, the benefits, the drawbacks, everything. That is called being objective while conducting the experiment. Okay, so if you are a scientist, you should not show any bias while conducting the experiment. You need to be being objective when you conduct the experiment. Then another way of avoiding bias is by conducting the peer review. So during the peer review, another scientist in the same field of study will review our experimental procedure, will review our means the data that we have recorded. They will repeat the experiment and check, and they will review the conclusion we made from the data. So we can avoid bias by being objective during the experiment and by conducting the peer review. So that is the answer for the question number 3. Then question number 5. Can you read question number 5? You find your friend, means your friend find that 90% of students in the cafeteria like pizza. 90% of students in the cafeteria like pizza. She says this scientifically prove that everyone like pizza. How would you respond? So like and dislike, is it scientific?
No.
No, right? Like and dislike is not scientific, right? Like and dislike, we cannot prove by scientific method. So it is a statistics, right?
Yes.
We cannot say everyone like pizza because 90% like pizza in that canteen, right? So it is a small sample. It is not scientific, right? If it is scientific, if we take in another place, means it should give same thing, means same result in every sample we take, right?
Yes.
Okay, so like and dislike are not scientific. We cannot, means opinion, emotions, like, dislike, we cannot prove by scientific method. So this we can say it is a statistics, right? 90% of the people in that canteen like pizza. From that statistics we cannot generalize that everybody like pizza, right? Even if we generalize it, that is not scientifically proven. Okay. Then question number 6. An accepted value for free fall acceleration is how much? Question number 6, we will write here. The accepted value of free fall acceleration is 9.8 meter per second squared. You can calculate the accepted value of free fall acceleration, means acceleration due to gravity near to the surface of the earth, that is 9.8 meter per second squared, that you can calculate by conducting an experiment using simple pendulum. Have you done this experiment in school?
No, not yet.
Okay, you can calculate the value of free fall acceleration, which means acceleration due to gravity, by conducting a experiment with a simple pendulum in the laboratory, and you did that and you got a value g equal to 9.4 meter per second squared. So the value you got is very close value, right? there is small difference of 0.4 meter per second squared. In an experiment with the pendulum, you calculate a value to be 9.4 meter per second squared. Should the accepted value be tossed out because of your finding? Do you have to toss and check? Means you need to depend on this value, or you need to depend on this value? Do you need to ignore this accepted value because in the experiment you got this? No, because when you conduct the experiment in the laboratory, there are chance of some errors. There can be error, like a systematic error will be there. There will be systematic error. Okay, means when you calculate the time, means when you measure the time period of oscillation, or when you measure the length of the pendulum, if the ruler is not perfect, it will cause systematic error. There will be random error. Random error means error due to the person doing the experiment. For example, reaction time. Okay. So when you conduct the experiment like that, there will be systematic error or random error. Means experimental error will be there, right? When we conduct the experiment in the laboratory, there are chances of experimental errors, and the small difference of 0.4 meter per second squared can be due to the experimental errors. Okay, and this 9.8 meter per second squared, that is the accepted value, which means they have done a lots of experiment. Okay, they repeated experiment many times. They have conducted different types of experiment to calculate the value of G, and different scientists done different experiment for long period of time, and they decide that, or they confirm that a value of acceleration due to gravity is 9.8 meter per second squared. Okay, that cannot be ignored by conducting one experiment in the laboratory, and we are getting a slightly different value, because the difference in our measurement can be due to experimental errors. It can be due to systematic error. Systematic error means error due to the mistakes in the instrument, and it can be due to random errors like parallax error or zero error, or sorry, zero error is reaction systematic error, like parallax error or reaction time error when you conduct the experiment.